Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 4. The lesson is called Some Polynomial Functions. Last time we have studied the meaning of polynomial function, and we said that the polynomial function is a rule in which this rule is a terms of x such that the powers of x must be natural number. Today, inshallah, we are going to study some special cases or some types of the polynomial functions. They are three types. They are the 0 degree function and the first degree function and the second degree function. We are going, inshallah, to study each type and how can we represent each type graphically and solve many questions about every type. Let's start the lesson. The first type is called constant function. Constant means stable or doesn't change. Here the function or y is stable, is constant number. This number, it doesn't change according the change of x. Okay, this number, this type of functions we using in the physics to represent the constant of constant of speed and the constant of distance, which give me the rest of a period or the rest of a car. Okay, this function has a form. First, this function is of 0 degree, and this function in the form f of x equal number. And as we said before, f of x is y, then y is a constant number. This number doesn't change whatever the change of x. Okay, for example, here in this example we have f of x equals 2, okay, or y equal 2. That means y here doesn't change whatever the change of x, so we called it constant function. Okay, for example, if x equals 0, then y or f of x equal 2. To represent 0 and 2, we are going to put 0 and 2 inside an order pair like this, and then we are going to represent this point graphically like this at the point 0 and 2 in this position like this. And if x equal 1, then also y or f of x equal 2. It represent in an order pair as 1 and 2. It represented 1 and 2 here in this position. Okay, and if x equal 2, then f of x equal 2 also. It represented here 2 and 2 in this position. Okay, now we found the 3 points are on the same straight line, and this straight line parallel to x-axis. Okay, but before drawing the line, we are going to put the data inside the table. In the first column or the first row, we put x and its results 0, 1 and 2, and in the second one we write y, its results 2, 2 and 2, because it's constant function. Then I'm going to draw the line like this, and this line, as we see, is parallel to x-axis, and it's a rule. Any constant function represented by straight line parallel to x-axis, as we see, represented by straight line parallel to x-axis, and this line passes through the point 0 and f of x, or intersect y-axis at 0 and f of x. This is 0 and 2. As we see, this is the intersection with y-axis 0 and 2. 2 here is the f of x. Okay, let's see some examples for the constant function. But before we see the examples, here we have this f of x equal to, I will write it here, f of x equal to represented by line passes through 2. Okay, for example, if we have line like this passes through 5, its function f of x equal 5, or its rule is f of x equal 5 because it passes through 5. Another example, if we have a straight line like this passes through 4, its rule f of x equal 4. Another example, if we have a line passes through 3, it's f of x equal 3, and here f of x equal 2, it passes through 2, and here f of x equal 1 because it passes through 1. Finally, x-axis passes through 0, so the rule of f of x is f of x equal 0. Okay, and this is a very important remark. Okay, when he asked me x-axis, then x-axis is f of x equal 0. Again, this line passes through 5, it's f of x equal 5. Here f of x equal 4, f of x equal 3, f of x equal 2, and so on. Okay. Here, example 1, complete the following. The x-axis is a graphical representation of the function f r to r. R to r, here r is the domain, and here r is the co-domain. Then x, as we see in the last example, f of x equal 0. This is the rule of f of x. Okay, the next one, f of x equal -3. This one is a constant function. That means this function is stable, doesn't change. Okay, then if he give me x equal 0, then the value doesn't change, it will be -3. Another example, if f of x equal 3, okay, then f of 5 plus f of -5. f of 5 equal 3 plus f of -5 also equal 3 because it doesn't change, it will be 6. Next, f of x equal 5, then f of 5 over f of 10. f of 5 equal 5, as we see here, and f of 10 also equal 5. 5 over 5 equal 1. Another example, if f of x equal 2, then 3 times f of root 2, it will be 3 times f of root 2 equal 2. Then it will be 2, 3 times 2 equal to 6. Number 6, the function f from r to r, where f of x equal 5. Okay, this is a constant function represented by a straight line parallel to what? Parallel to x axis and intersect y axis at the point, as I said last time in the rule, 0 and f of x. Here f of x equal 5, it will be 0 and 5. If I need to draw this one, it will be like this. One, two, three, four, 5, and this is x-axis. Then the line will intersect y-axis at 5 like this, and in the same time it's parallel to x-axis. Okay, this is the constant function f of x equal 5. Now I'm going to study the second type with us, which called the linear function. The linear function. Linear, we have studied in the second prep. It was called linear relation, but now we are going to study linear function. It's exactly as we studied in the second prep. The linear relation is the same as the linear function. It's the first degree function. Okay, and this function is a polynomial function of first degree. For example, if we have f of x equal x plus 2 like this, okay, this one is not a constant. It doesn't constant values. For example, if x equals 0, then y equal 2, y2, because 0 plus 2 equal 2, and we will put 0 and 2 inside an order pair like this, and graphically we represented by the point 0 and 2 as we see here. Okay, if x equal 1, then y equal 1 plus 2 equal 3. It will be 1 and 3. 1 and 3 as we see here. Okay, if x equal 2, then y equal 2 plus 2 equals 4. Then it will be 2 and 4. 2 and 4, it will be 2 and 4 here in this position. If x equal 3, then y equal 3 plus 2 equals 5. It will be 3 and 5. 3 and 5 will be here in this position. As we see, the points are collinear. Collinear, okay, means in the same straight line. Then we can connect them with a straight line like this. This straight line intersect y axis here at the point 0 and 2. It's very important to find the intersection with y axis at x equal 0. It's a very, very important remark. Okay, intersect x axis at 0, 2. Okay, intersect y axis at the point 0, 0 and 2 as I explained here at x equals 0. It's a very important remark. Don't forget this remark because we are going to use it in the next questions. Okay, let's solve the next example. In this example, represent graphically and find the point of the intersection of the straight line with which represent the coordinate axes. Okay, first we are going to draw a table like this. F of x equals 3 plus 1. First we are going to draw the table like this. Inside the table we are going to write x here and y here. Y means f of x. Okay, then at x we are going to write 0, 1 and 2. You can write any numbers but except 0, 1, 2 and 0, 1 and 2, but 0, 1 and 2 are the easiest points, so I'm going to use 0, 1 and 2 forever in the first degree equation. Okay, here at x equals 0, 3 times 0 plus 1 equals 1. At x equal 1, 3 times 1 plus 1 equals 4. And 3 times 2 plus 1 equal 7. Then I'm going to draw the graph like this. 0 and 1 here in this point. 1 and 4 here. 2 and 7 here in this point. Then I'm going to connect them by straight line like this. Okay, and they are collinear, represented by straight line. Okay, this line intersect as we see y axis. Y axis at 0 and 1. Okay, to find the intersection of x axis, it's negative half and 0. Okay, but I can, it's negative 1 over 3 and 0, but I can check this one by solve it algebraically. How come? By put f of x equals 0 at f of x equal 0, therefore 3x plus 1 equal 0. I'm going to send 1 there as minus 1, therefore 3x equals negative 1, and then I'm going to send 3 as divided by 3, then x equal negative 1 over 3. Therefore, the line intersect x axis at the point negative 1 over 3 and 0, and this is a very important remark. The next example, example 3, number 1, the linear function given by the rule y equal 2x minus 1 represented graphically by a straight line intersect y-axis at the point what? First, the point of the intersection of y-axis is 0 and number. Then I'm going to put 0 in place of x, then y equals 2 times 0 minus 1 equal 2 times 0, 0 minus 1, negative 1. Then this one is negative 1. The next example, the linear function given by the rule y equal 2x plus 6 represented graphically by a straight line intersect x-axis. To find the intersection of x-axis, put 0 in place of y. Then y equal 0, therefore 3x plus 6 equal 0. Send 6 to be minus 6, then 3x equals negative 6. Send 3 to be divided by 3, then x equal negative 6 divided by 3 equal negative 2. Then the point will be negative 2 and 0. Number 3, if a and 3 located on the straight line which represents the function f from r to r, where f of x equal 4x minus 5, then a equal. As we said before, this one is x and this one is f of x or y. Then in place of f of x, I'm going to write 3. In place of x, I will write a. It will be 4a minus 5. Then I will switch the equation, then 4a minus 5 equals 3. Send 5 there, then 4a equals 3 plus 5, which is 8. Then I will send 4 divided by 4, therefore a equals 8 divided by 4 equals 2. Then a equals 2. The next one, the straight line which represents the function f from r to r, f of x equal 5x minus a, intersect y-axis at the point b and 2. b and 2, that mean b equals 0. Okay, because the point which belong to y-axis, its x coordinate equals 0. Okay, now I need to find a. Here 0 and 2 belong to this function. I will put this one in place of x and this one in place of y. Therefore, in place of f of x, I will write 2 equal 5 times 0 minus a. 5 times 0 equals 0. Then negative a equal 2. Send negative there divided by negative 1. Then a equals 2 divided by negative 1 equals negative 2. Then a equals negative 2. Now we are going to study the last type, which is called the quadratic function. Let's start studying this one. The quadratic function. Quadratic function is the function of second degree. For example, if f of x equal x power of 2 minus 2, now we have here x power of 2 minus 2, it's second degree function, okay, because it's contain x power of 2. But to solve this one, he must give me interval included x. Here x belongs to negative 3 and 3, from negative 3 to 3. Okay, now to represent this one graphically, we are going to draw table like this. Here we are going to write x, and here we write f of x, and the numbers of x giving from this interval from negative 3 to 3. Okay, negative 3 here. To find the value opposite to negative 3, we are going to put negative 3 power of 2, 9 minus 2 equals 7. And here, if x equal negative 2, this negative 3 and 7 represented by the point negative 3 and 7 here. Okay, and then here we are going to put negative 2. Negative 2 power of 2 minus 2 equal 2. It will be negative 2 and 2 here in this position. And here negative 1. Negative 1 power 2 minus 2 equal negative 1. Negative 1 and the negative 1 here in this position, as we see. And at x equal, here x equals 0. 0 power 2 minus 2 equals negative 2. It will be 0 and negative 2 here. And x equal 1. 1 minus 2 equal negative 1. You find here this one were repeated. 1 and the negative 1. Okay. 1 and the negative 1 it will be here in this position. And then x equal 2. 2 power of 2 minus 2 equal 2. 2 and 2 it will be here in this position. And at x equal 3. 3 power 2 minus 2 equal 7. We found here negative 1 and the negative 1. It's symmetric. 2 and 2. It's symmetric as we see here. And 7 and 7. It's symmetric. Okay. The point 3 and 7 here. When we connect the points by your hand, it gives me a curve like this. This curve is called U-shape. U-shape, and it has another name called parabola. Okay. This curve represents the second degree function or the quadratic function, as I said before. Okay. Now I'm going to teach you another way to complete this table by using the calculator like this. Okay. To complete this table using the calculator, okay, we are going to use the calculator like this. Okay, press shift table here, excuse me, mode, table is number 7, then I will press 7. It appears f of x like this, and I will write this function here in the calculator. How come? X here in the bracket, there I will press alpha x and then write power 2, then minus 2. Okay, then I will press equal. Okay, it gives me g of x. Okay, your calculator doesn't include g of x. I will press equal. It asks me the start. This is the start of the function. It's negative 3. I will press negative 3 equal. And he asked me the end. The end is 3. I will press 3 equal. Then he asked me step. Press equal. He gives me the table like this. Negative 3 and 7 here like this. Negative 2 and 2 here, negative 1 as we see. Then by using the pointer like this, go down, -1, -1, 0, -2, 1, -1, and go down, 2, 2, 3, 7, and this is the table represent the function f of x equal x power 2 minus 2. You can use mode 7 to write the table of any quadratic function. It's very easy. Okay, now let's complete the lesson. Here we have in this one, as we said, quadratic equation or the second degree equation give me U shape like this. Okay, here we have a point at the middle of the U shape or the curve. This point called the vertex of the the vertex of the curve, like this. The vertex of the curve is this point, as you see. Okay, now if he asks me the vertex of the curve is this point, which is 0 and -2. Again, it's 0 and -2. Then I will write here 0 and -2. And by looking to the table, we have here also 0 and -2. And from the table, 0 and -2, as you see, this is the vertex of the table. Okay, or the vertex of the curve. Then I can find the vertex by two different ways. From the table, the vertex appears here, is the center of the table of the vertex from the graph, and from the table, the center of the midpoint of the middle point of the table is the vertex. Okay, now he asked me the minimum value or the maximum value. As we see at y-axis, why y-axis? Because the function means y-axis. F of x means y. Then the function, the values of the function represented at y-axis. Okay, here the vertex is the bottom of the curve, is the least point or the minimum point of the curve. Okay, and the rest of results go up like this. As we see, the values start from here and go up. -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and so on. Then the values of the function started with this number, which is -2. This one called the minimum value. As you see here, then -2 is the minimum value. Okay, then I will write -2 because the vertex intersect y-axis at the curve. The least point at the curve is -2, as we see. Okay, we can find the minimum by another way. The minimum value is y coordinate, and y here is -2. Okay, now there is a straight line intersect divided the curve into two symmetric shapes. This line at the middle like this line called axis of symmetry. Okay, the axis of symmetry appears like this. As we see, this is the axis of symmetry. The axis of symmetry is the line that divides the shape into symmetric shapes. Okay, here the line intersect x-axis at 0, as we see. So this line, its equation is x equal 0. So when he asked me the equation of the axis of symmetry, we search about the line that divides the shape into symmetric shapes and search about the intersection with x-axis. This will be the equation of the axis of symmetry. But here you must write x equal. Don't forget to write x equal. Okay, another way to find the equation of axis of symmetry, you can find the axis of symmetry from the vertex. Here 0, then the vertex is x equal, the equation of axis of symmetry is x equal 0. Then from the vertex we can find 3 items. The vertex itself 0 and -2. the x coordinate is the axis of symmetry, the y coordinate is the minimum value or maximum value. Another example. Here we have f of x equal 3 minus 2x minus x power 2. Okay, the first step here, I'm going to, before solving this one, we have to find the interval. Here are the interval from negative 2 and 4. Okay, the curve appears like this. First we are going to draw the table, and up here we are going to write x, and here f of x. Okay, the first x with us is negative 4. Here 3 minus 2 times negative 4 minus negative 4 power of 2, it equals negative 5. Negative 4 and negative 5 appears in this position, negative 4 and negative 5 here as we see. The next point, negative 3. 3 minus 2 times negative 3 minus negative 3 all power of 2 equals 0. Negative 3 and 0 appears in this position. The third point is negative 2. 3 minus 2 times negative 2 minus negative 2 all power of 2 equals 3. Negative 2 and 3 appears in this position. And the next point is negative 1. Negative 1, 3 minus 2 times negative 1 minus negative 1 power of 2 equals 4. Equals 4. Negative 1 and 4 appears here. And the next point is 0. 3 minus 2 times 0 minus 0 power 2 equals 3. The next point, x equal 1, it's here, 0 and 3. The next point, x equal 1. 3 minus 2 times 1 minus 1 power 2 equals 0. 1 and 0 here in this position. And x equal 2. 3 minus 2 times 2 minus 2 power 2 equals negative 5. Appears here in this position. Then I'm going to connect the points like this. It gives me a curve like this called N shape. This one is N shape. Okay, now by using the calculator like this, I will press mode 7 or mode table. Then I will write the function 3 minus 2 x minus x power of 2 equal, you haven't g of x, it's in my computer calculator. Okay, equal, the start here is negative 4, the end here is 2, the step is 1. I will press equal direct. Okay, negative 4, negative 5, negative 3, 0, negative 2, 3, 1, negative 1, 4, 0, 3, 1, 0, 2, negative 5, and this is the end. Okay, this is the calculator. Now I need to find the vertex of the curve. This is the vertex of the curve. This point is negative 1 and 4. And from the table here are the vertex of the curve. Don't forget, y coordinate is called the minimum or the maximum. But here the vertex at the top of the curve, then this is the maximum point. As you see, the maximum point is 4. Why 4? Because the values start from 4, the values at y from 4 and go down to with no end like this. Then the maximum value for y here is 4. Okay, as we see, it's 4. Okay, then we can find the maximum value by two different ways, by using the curve or by using the vertex. It's 4 here. Okay, now we are going to find the axis of symmetry. The axis of symmetry is a line that intersects the curve like this. This is the axis of symmetry. The axis of symmetry intersect x at this number, which is -1. Then the equation of the axis of symmetry is x equal -1, as we see, or from here x equal -1. Don't forget to write -1, to write x equal -1. Okay, let's solve the next example. Here in this example, example 4, represent the following graphically, and from the graph deduce the coordinates of the vertex of the curve and the equation of the line of symmetry. This is number 2, and the minimum or maximum value. Okay, first the function here is from -4 to 2. First I'm going to write the table like this. Here x and here f of x. X -4, -3, -2, -1, 0, 1, and 2. At x equal -4, okay, y equals 9. -4 power 2 plus 2 times -4 plus 1, or by using calculator as I explained before. Okay, I will explain it again like this. Mode table or 7, then x power 2 plus 2x plus 1 equal, start is -4, end is 2, step is 1, -4 and 9, -3 and 4, -2 and 1, -1 0, 0 1, 1 4, 2 9, and this is the end of the table. It will be -3 and 4, 1, -2 and 1, -1 0, 0 1, 1 4, 2 and 9. This is the first step. The second step, I'm going to draw the graph like this. -4 and 9 here in this position, -3 and 4 here, -2 and 1, -1 and 0, 0 and 1, 1 and 4, 2 and 9. And then I'm going to draw the curve by your hand like this. This is the curve of the table of the function. Okay, now I need to find the vertex. The vertex appears here. It's -1 and 0, or by using the table, it's the center of the table, which is -1 and 0. The vertex formed from x and y. Okay, here the minimum value. Why this one is minimum? Because it's U shape and the vertex here at the bottom, so it's the least point, so it's minimum. The minimum value is 0 from the vertex, or it's opposite to 0 here. Okay, now the equation of the axis of symmetry, it's x equal, and this number is -1, or by using this line. Okay, the line like this, this line, the line that divide the shape in two symmetric shapes. This line intersect x-axis at -1, so x equal -1. The next example. Here example 5. The curve of the quadratic function has maximum value if the sine of x power of 2. By looking to the previous examples, the first example, x power of 2 was positive, okay, and at that case the shape was like this at x power of 2 is positive, and this give me minimum value. And if the shape is like this, then x power of 2 is negative, okay, and this give me maximum value. This is maximum and this is minimum. Okay, here to give me maximum, then the sine of x power of 2 is negative, okay, and it has minimum value if the sine of x power of 2 is positive. The next one, as representing f of x equal ax power of 2 plus bx plus c, where a belong to r star means r without 0, then the x coordinate of the vertex of the curve is the vertex, remember this rule, is negative b over 2a and f of negative b over 2a. This is a very important rule. The coordinate of the vertex is negative b over 2a and f of negative b over 2a. Okay, then the x coordinate is negative b over 2a. The next example, the curve of the quadratic function which define on R has maximum value. Then this curve is opened. If the function has maximum, it opens downward. Or you can write down. Okay. Number 4, if the point of the vertex of the function 2x power of 2 minus 4x plus 5 is, okay, this is the rule of the vertex, negative b over 2a. Okay, here this one is a, negative 4 is b, 5 is c. Okay, negative b over 2a equal negative 4 over 2 times 2, which is equal 1. Okay, then x equal negative x equal 1. Okay, y equal, or f of x equal, or f of 1 equal f of 1, which is equal to times 1 power of 2 minus 4 times 1 plus 5. This one equals 3. Then the point finally will be 1 and 3 by using this rule of the vertex. Okay, the next one, the curve of the function such that f of x equal x power of 2 plus c passing through 0 and 2. As I said before, 0 here is x and 2 is f of x. Okay, then in place of f of x I will write 2 equal 0 power of 2 plus c. 0 plus c equal c, then c equal 2. The next one, negative 1, negative 2 and y belongs to the curve of the function f of x equal x power of 2 plus 1, then y equal what? Here this one is x and this one is f of x. Then y equals negative 2 all power of 2 plus 1, then y equal 5. The next one, 3 and 2 is the vertex of the curve. Okay, x and y. The vertex of the curve of quadratic function f, then the equation of the line of symmetry. As I said, the line of symmetry comes from here, from x. It will be x equal 3. Don't forget to write x. Okay. The next example, in the opposite figure, represent the curve of the function f of x equal m minus x power of 2, where OA equals 4 units. Then find, number 1, the value of m. Okay. To find the value of m, we need to write a. A here equals 0 and 4 because this distance equal 4. Okay, then of course this one is x and this one is f of x. Then I will put in place of f of x, I will write 4 equal, in place of x I will write 0, m minus 0 power of 2. M minus 0 equals m, therefore m equals 4. This is the first question. The second one, the coordinates of B and C. B here equal x and number, x number and 0, and C here equal another number and 0. Okay, I don't know the number, the coordinate of x. I will do what? The function will be f of x equal 4 minus x power of 2. Okay, at the intersection of x-axis, we put in place of f of x 0. Therefore, 0 equal 4 minus x power of 2. I will send 4 here and x power of 2 here. Therefore, x power of 2 minus 4 equals 0. I send 4 here with negative and the negative x with positive, like this. Now I'm going to factorize x, negative, positive, and 4 will be 2 times 2 equal 0. Then x minus 2 equal 0, and x plus 2 equal 0. Then x equal, I will send 2 there, 2, and x equal negative 2. Okay, now I have two values of x, negative 2 and 2. So B will be 2 and 0, and C will be negative 2 and 0. It's very clear because C in the left side and B in the right side. So B equal 2 and 0, C equal negative 2 and C and 0. Finally, find the equation of triangle which represent A, B and C. Here we have B, C, and like this we have a triangle. This triangle, its base equal 4 and its height equal 4. Then the area of triangle ABC equals half times base, which is 4, times height, which is 4 also. Half times 4 equals 8 area units, because it's a graph. And this is the end of the video. I hope it was helpful for you. See you in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.